So, multiplying matrices. Okay, it's a little complicated, it's a little difficult, but it's not the worst thing ever. Okay, it's not like it's not like factoring. It's not terribly difficult in the thought process sense, I guess is a good way to put it. You do have to understand when and what to do, though. Okay, and that's kind of the hard part. So let's see. First slide. Let's get all this stuff up here and then talk about it. There we go. All right. Now, this is probably the most important slide over the day, right here. Okay? It tells you when, how, and what. All right. So, instead of yesterday when we multiplied a matrix by just a number, or a matrix by just a number, today we're going to multiply these matrices together. Here's how you do it. First off, when you can do it. You can multiply two matrices, A and B, if and only if the number of columns in A equals the number of rows in B. Number of columns in A equals number of rows in B. Columns in A, rows in B. Alrighty? Now, you write dimensions of matrices rows by columns. Right? We did that yesterday. Row by column, row by column, row by column. Which means this one here is A's columns. This one here is B's rows. When you write it, and when you write it out this way, that means the middle two numbers, the inside numbers, they need to be the same. That's all there is. If you do it row by column, in order to multiply matrices together, the inside two numbers of the dimensions have to be the same. That's all there is. Okay? Does that make sense? Okay? If it goes rows by columns, your inside numbers have to be the same. Throw one more at you. Your new matrix, your answer matrix, is going to have dimensions that are this guy's rows and then B's columns. Okay? So the inside numbers have to be the same. The outside numbers are what make your new dimensions. That's how you know. Your inside numbers tell you if you can do it. Your outside numbers tell you what size of matrix you get. Okay, make sense? Okay. Okay, so first off, we're going to do this. Determine whether each matrix product is defined. That means if you can do it. If so, state the dimensions. So, number one, matrix A is a 3 by 4. Matrix B is a 4 by 2. All right, now this is just theoretical. This is if we can do it. Next slide, we're going to actually do one. Okay, so this is just seeing if we can do it. So, can we multiply A and B?
Yes.
Yes, inside numbers are the same. See that? You got 4's here, 4 there. Okay? That's how you know you can do it. What size matrix do you end with?
3, 2.
3 by 2. Okay? Your outside numbers. 3 by 2. Okay? Inside numbers tell you if you can do it. Outside numbers tell you what you end with. All right? Now, let's answer Burke's question. A times B you can do. What about B times A? No. Okay? No, you can't. Because you have a 4 by 2 in B, a 3 by 4 in A.
What if the problems don't switch like that and they match?
If you can switch them and they match, which will happen, then yeah, you're fine. But I'm showing you that and here's what I'm getting at. You can't. It's not like 2 times 3 and 3 times 2. That's 6 no matter how you slice or dice it. Here, your order is super important. Okay, A times B. Well, even if it would work, you'll see in a minute that we'll have one that you can switch them and still multiply it twice. A times B does not give you the same thing as B times A, even if it would work. Okay? So the order you put these matrices in, left, right, is super important also, because if you put them in wrong, you may say it doesn't work, it's undefined, when in reality it actually works. And then you're losing a lot of points because you're supposed to be able to do that problem and you didn't do anything with it. Makes sense? Your dimensions are the main important part here, guys, okay? Number 2, can you do it? No. 3, 5, can't go. All right, find x, y. If x equals 6, negative 3, negative 10, 2. Times y, which is negative 5, negative 4, 3, 3. Okay? Let's make that, I want to make that just a little bit smaller on my side of things. There we go. Okay. Okay. First thing you do. This matrix, the first one is a 2 by 2, right? The second one is a 2 by 2. So can we do it?
Yes.
Yes, we can. What is your final matrices dimensions going to be?
2 by 2.
A 2 by 2. So this is going to equal another 2 by 2 matrix, okay? So we're going to end with a 2 by 2 matrix. Now, a 2 by 2 matrix has how many elements?
4.
4. Right? These all have 4. This one has 4. They all have 4.
Wait, how did you get a 2 by 2?
Your inside numbers are the same. Your outside numbers are 2 and 2.
Where did you get that from?
Where did I get what from?
The 2 by 2?
This one here?
Oh, okay.
Okay.
And then,
Now, we're going to make these 4 elements. You don't know how we're going to make them yet, but we know there's going to be 4. Okay? So here's what I want you to do. I want you to write A, B, C, and D. Yes? Yeah. Okay? A, B, C, and D. All right? Those are the 4 elements. We're going to give them letters from now, even though we don't know what they are. Okay? Everybody good? We're going to find A first. Okay? So I'm going to go down here. I'm going to write A equals. Which goes first, rows or columns? Rows. Okay? Rows go first. So I want you looking at this row right here. And what goes second? Columns. Okay? Second matrix C, I want you looking at that column right there. Okay? A in your answer matrix is your element in the first row, first column, right? First row, first column. So you're going to make that element by doing stuff with this guy's first row and this first column. Okay? What you do is this. The first element in this row is what? 6. First element in this column is what? Good. We're going to multiply those. Okay? And I'm going to put it like that. Just so we can get processed. Okay? Just hang tight with me here. Okay? Plus. What's the next element in this row? Negative 3. What's the next element in the next column?
Negative 3.
3. Sorry. Next element. Go down. 3. Multiply them. Negative 3. Positive 3. You multiply the first in this row by the first in this column, added with the second in this row and the second in this column. So that's how you make your first one. Okay? Now, go to B. I'm going to circle it as soon as I get up there. I'm going to circle it in blue. B, blue, C, Q. Okay? Now, element B is in the same row, right? Still in the first row. So you're going to look right there. But it's in the what column? Second column. So you're going to move to this column. But you're going to make your equals line down here the exact same way. First times the first, second times the second. Okay? So, 6 is the first one in this row, times negative 4, first one in that column. That goes next. 6, negative 4. Added with Second in the row, second in the column. -3 and 3. Good so far. Now, since you are out of this column, we're done with B. We're moving to C. I'm going to circle it in yellow. Okay. C is in which row?
Second column.
Second. Easy.
Second row.
Second row. So in the first matrix, we're going to move to our second row. It's in the which column? First column. So in your second matrix, we're going to move to back to the first column. Same way. Multiply the first numbers, multiply the second numbers, add them up. So -10 times -5 plus -2 times 3. I didn't. Now let's make D. I'm going to circle it in white. Alright, so D is still in the second row, but now D is in the second column also. So use that. So D equals -10 times -4 plus -2 times 3. Okay? Don't take one just yet. Your next step.
Wait, what's C? It was that's -2 and what? -2 and 3.
Yeah.
So C and D both get multiplied by the first column.
Right.
That doesn't make any sense to me. Like, why don't we use the second? What do we use in the second column?
Now, last step. Actually clean all this up. Okay? Yeah. Okay. Because now you got to go and actually make those numbers. Okay? And this, the nice part about setting it up this way is you can just put that in your calculator. All right?
And then the end.
And then once you have that,
The end results would just be
there you go.
the matrix.
Yep. Okay? See why I'm doing the variable thing now? Because once you do that, then you just write that matrix, placing the variables, and you're done. Okay? So now all you got to do is do all 4 of these operations. So 6 times -5 gives you -30. Minus 9 gives you -39. Okay? And that's going to go over here. Here's our answer matrix. That's going to go. Second one, do the blue. 6 times -4, -24, minus 9. -24 minus, other way, -24. -24 minus 9.
Wait, hold on. How do we get 39?
Plus,
Negative.
it's
Oh,
negative,
but it's
negative,
negative.
-3.
But it's- yeah, I get what you're saying.
-3. Yes.
It wouldn't be plus -9. It'd just be minus 9.
Minus
First
either one.
How did we get -39?
This is -30 right here. -30 plus -9.
Where'd you get -9 though?
-3 times 3.
Oh, never mind. I thought we were doing. I'm thinking that we're doing 6 times -6, or 6 times -5, and then 6 times 3.
No, these are 3s.
So why wouldn't we do negative? I'm confused.
Minus 9 was what? -33, is that right?
Yes.
Okay.
I can't move this.
So basically, we're doing both of the rows with a different column.
Right. Right.
Okay.
Okay. 50 minus 6 gives you 44. Alrighty. And then 40 minus 6 gives you 34. There we go. And then now that you have them, I already started it, but I forgot to do the rest. Then fill it in. So A is -39, so we put that here, just like we did up here, right? Okay, B is -33, so we put that next to it. C is 44. D is 34. And that's your answer. We're going to find YX. Okay?
Ain't the same thing every time? It's the same thing every time?
No. You'll see. It'll be different.
What was the last? What was the
First one was XY.
Okay.
This one.
Fine.
Now we're doing
Four?
now we're doing y
Oh,
yx
that's
yx.
So that means that.
So now you got to write y first, right? And x second, which will change your numbers. Okay, so don't just assume that it's going to be the same thing that we just got. Okay. Now, what won't change on this one is your dimensions, right? We flip-flopped a 2 by 2 and a 2 by 2. We still have a 2 by 2 and a 2 by 2. We're going to end up with another 2 by 2. So you can still give it your same variables. Okay. So we'll start with A. A right there. A is in your first row in your first column. I hardly see the white on the grayish, but you got the point. What's up, Bo?
Okay. Do we win? Okay, you know, do the thing, right? Do we supposed to put? Okay. Walk up.
Okay. I'll hold your stuff. Okay. Well, here, show me on the board. Show everybody.
When do
No. Go show everybody.
Oh.
Don't just
write down here though.
take a marker. Okay, so we go first times first, so -5 times 6 plus -4 and -10. Okay.
B would be the same thing.
B would be the same row,
Would it be the second column?
but the next column in the second one. There you go. Same.
Oh, I think I get it now. So we're basically just like flip flopping back and forth.
There you go.
So C would be back to the first column.
Back to the first row.
Or the first.
Sorry, you were right. First column, second row,
Yeah.
and then second row, second column for D. Okay.
So,
Burke.
okay.
So for B, we go -5 and 6. Nope, sorry, hold up. -5 and -3. Plus, same row, that column, -4, -2. Good.
I think I understand.
Okay.
It's
Now
just
for
kind of hard for you to
It's
explain
it.
visual.
So for C, we move down to our second row. So we're going to move down to the second row here, but we're moving back to that first column. Okay? Everybody good? So 3 with 6 plus the next 3 with -10. And then for D, you're still in that second row, but now you're in that second column. So 3 times -3
It was 3 plus 3 -10.
plus 3. Yep. Plus 3 times -2. Yes. Yes, dear. Okay. So then now, once you set this up, and this is, gosh, I'm so happy with myself, and I'm bragging on myself all day about this. I've been patting on myself on the back because this is so well organized now, and I love it. Just multiply these out, get your numbers, put them in the matrix.
It's way better
Okay.
than last year.
It's
So like 5 times 6, that's, no, -6, that's -30. Then that's +40. And then you add, oh, okay. Yeah, I was just confused. And then, yeah, 10. Okay, yeah.
Okay.
Yeah, I was confused with it. Overall, I understand how to do the problem.
not 6, 8. 15 plus 8 gives you what, 23?
Question is,
18, yes, sir.
so what's gonna happen when we get like 3 by 3?
You won't get a 3 by 3. The biggest I'm going to make you guys do is what you'll see in a second. Okay, the biggest I'm going is 2 by 3 and 3 by 2s. Okay, you will never go 3 by 3. Okay. Okay. The biggest you go is 2 by 3 and 3 by 2s. Okay. May result in a 3 by 3, but you won't multiply 2 3 by 3s. Okay.
Say that was gonna be a lot.
So let's see. 18 plus negative 30 gives you what? Negative 12,
Negative 12. And then D.
and then D ends up being
Negative 15.
negative 9. There you go. Jerry, you're on it, dude.
No, it's too easy.
Okay. Then write them out. 10, 23, negative 12, negative 15. Now, this is as big as they'll come, all right? Either 2 by 3s or 3 by 2s, okay? We're going to do GH. So, 1, 3, negative 5, 4, negative 2, 0. Times 2, 3, negative 2, negative 8, 1, 7.
Can we just flip over?
Hmm?
Can we just flip it over? It'd be the same number.
Okay? So, and I suggest you do the same setup every single time. Okay?
Wouldn't it be?
So, hang tight.
Or ABC?
So go 2 row, 3 column, right? 3 row, 2 column, right? Equals. Can you do it?
Yes.
Yes, insides are 3s. Outsides are what?
2.
2s. Now, you're going to have one on homework where the insides will be 2s, the outsides will be 3s. Okay? We'll talk about that on Monday.
Over the weekend?
Yeah, huh? I know. Okay? I know. All right? But this one's going to end up being a 2 by 2 again, right? So A, B, C, and D.
Wait, so how will we know that from the outside?
For outside numbers, right. Insides are the same. Outside numbers give you your new dimensions. Okay?
I should probably write that down and highlight it.
They can be different though, can't they? On the outside, got the number.
Outside don't have to be the same, correct. Outside does not have to be the same. This just so happens that so far they have been. Okay? So, let's make A. This row, that column. Notice the only thing that changes instead of 2 multiplications now, you have how many?
3.
You got 3. That's all that changes. Okay? That is all that changes, is how many multiplications you have. Okay? So, we go 1 times 2 plus 3 times negative 2 plus negative 5 times 1. Everybody good?
That's negative 5. Okay.
Negative 5 here times 1 here. Okay? Make B. Same row. Next column.
Oh, we read it from H, right?
Right. So
Okay, why didn't we go all the way down?
I did.
No, I'm saying like why didn't we go that way?
1, 2, 3,
You know
negative
what
2,
I'm saying?
negative 5, 1.
Oh, I get what you're saying.
Okay.
I thought we were supposed to go like 1 and then multiply 1 by all the columns.
No. You do this one times this one, that's it. Each one gets used once, right? 3, negative 2, negative 5, 1. Okay? So B, 1, 3. 3, negative 8, negative 5, 7. C. Done with that row. Go to your next row. C equals 4, 2, negative 2, negative 2, 0, 7.
So C is in the second column.
Right. C's in their first column, right? Right here. So you use the first column here. D's in your second column, second row. So you use second row, second column. Right here. Right here. So B. -4, 3, negative 2, negative 8, 0, 7.
I see that.
You get, or at least you should be negative 9, negative 56, 12, and 28. Alrighty?